Good morning, friends. I am Loganathan, Assistant Professor from Nanda Engineering College. Topic is here finite element analysis. So, what is meant by finite element? Finite element analysis. A small unit having a definite shape of geometry, then analysis in a physical and mathematical approaches. Then history of finite element method. Then first starting from 1941, Henry Cobb proposed to framework method. Then next is a finite element name. First name created in a finite element method name is a year of 1960 Cobb made of. The name is finite element method and continue the 1970, 1980 and 2000. Then continue the process of history of finite element method. Then next one is a common type of element. Then common type of element that is called as one dimensional element, two dimensional element and three dimensional element. Then one dimensional element is called as bar element, then beam element, truss element and frame element. Two dimensional element, triangular element, quadrilateral element and plate and cell. Three dimensional element, tetrahedral and rectangular prism bricks. That is called as common type of elements. That is called element type. Next one is element type, one dimensional, two dimensional and three dimensional simple diagrams. That is called element type. Then next one is a discretization concept. Then discretization is called the art of subdividing system into convenient number of small units. That is called as discretization. Then type of discretization is called artificial discretization and natural discretization. That is a discretization. Some example of discretization: one dimensional frame element, two dimensional triangular element, then three dimensional brick element is called discretization elements. Example: basic concept of finite element. Any continuous solution field such as stress, displacement, temperature, pressure can be approximated by discretized model composed of a set of piecewise continuous function defined over a finite element of subdomains. That is a basic concept of finite element methods. Introduction of finite element. Introduction of finite element is called, then first create in a node or point. Then node 49 is a one node. Then 42 is a second node. Connecting between two nodes 42 and 49 is called as element. Then connecting between two nodes is called as element. Then shape finite element. A small unit having shape of geometry. A small unit, for example, triangular. A small unit having different shape of elements called finite element method. Then for example, one node and then second node connecting between two nodes is called as one element. The development of finite element equation. Development of finite element equation, that is a simple direct method, variational virtual work method. Then third one is a weighted residual method. Then merits and demerits with application of finite element analysis. Advantages of finite element methods are merits. FEM, finite element method, can handle irregular geometry in a convenient manner. Then second one is a handle general load conditions without difficulty. Then third one is a non-homogeneous material can be handled easily. Then fourth, higher order elements can be or may be implemented. Disadvantages or merits of finite element method. It requires digital computer and fairly extensive. Second one is it requires longer extension time compared with the finite element method. Output result will be considerable. Application of finite element method: structural problem and non-structural problem, heat transfer analysis and fluid flow analysis. Then basic steps of finite element method. First one is creating a domain discretization, the art of subdividing system into convenient number of small element. For example, triangular, line or rectangular. Select element type. Then there is a element type, shape and approximation. Drive element equation, variational and energy method. Assemble element equation from global system. F is equal to K into U. F is equal to force, K is equal to stiffness matrix, U is equal to nodal displacement. Then study material is using a finite element analysis. Explain different methods of weighted descent method. First one is a point correlation method. Then second one is a subdomain collection method. Then third one is a least square method. Fourth, Galerkin method. Point collection method is equal to residual function. Residual function or residual are said to be 0. Subdomain collection method, residual domain integral r dx equal to 0. Domain integral r dx equal to 0. Then third one is a least square method. I is equal to domain integral r square dx equal to residual square r square dx equal to minimum. Therefore, dou I divided by dou s equal to 0. Then last one, Galerkin method, is a domain integral residual and trial function y of x. Trial function are said to be 0. It is called as a weighted residual method. And another one method is a variational method is using in a Rayleigh's-Rich method, can be solved in a beam problems. Rayleigh's-Rich method and using in a approaches in a polynomial series and trigonometric series. Polynomial series and trigonometric series using in a Pascal triangle. And limit or error as a convergent method. Convergence equal to types of element. It is called two types of conversion, H conversion and P convergence. H conversion is equal to increase the number of element and order of polynomial can be constant. And another one is a P convergence equal to increase the order of polynomial and number of elements equal to constant. Then illustrative example of FEA. And then next one is a engineering application of finite element method. Area of equal to civil, aircraft, heat conduction, geomechanics, mechanical, electrical, electronics. That is some application of FEA. Then special cases of one elastic bar, equilibrium, strain, displacement and stress strain loss. Then two-dimensional elastic problem, plane stress and plane strain. Some example of plane stress equal to in which the plane stress, normal stress and shear stress is directly perpendicular to the plane or assumed to be 0. That is a plane stress example. Plane strain, normal strain and shear strain is directly to the perpendicular to the plane or assumed to be 0. Then third one is a 3D elastic problem using in a axis symmetric analysis. Axis symmetric analysis. Then using in a some example, simple example in a FEA. Then simple example of FEA compared with ANSYS software packages. The structure shown in a figure, that is a stepped bar. Stepped bar structure shown in figure is subject to an increase of temperature 80 degrees centigrade. Determine the displacement, stress and support reaction. Then first one left end fixed, then other end right end fixed. Then three material can be compared: bronze, aluminium, steel. Three material and bronze, aluminium, steel material. Then length 800 mm, 600 mm, 400 mm. Then bronze material area 2400 mm square. Then Young's modulus 83 gigapascal. Then 83 gigapascal converted to Newton per mm square. Then giga is equal to 10 to the power 9. 1 Pascal is equal to 1 Newton per meter square. Therefore, 83 into 10 to the power 3 Newton per mm square. Then alpha coefficient of thermal expansion 18.9 into 10 to the power minus 6 per degree centigrade. Then simple solve for element 1, node 1 and 2. Then K is equal to stiffness matrix, K is equal to AE divided by L, 1 minus 1 minus 1 1. Then another one is a node 2 and 3 element 2, node 3 and 4 element 3. Then assembling of equation, then K is equal to 249 minus 249 0 0. Then simple compared to simple properties of stiffness matrix, then that is a 4 into 4 matrix, that is a square matrix. Then next, any row or column must be equal to 0. Simple checking, 249 minus 249 is equal to 0. Then next one is a diagonal matrix are positive, 249, 389, 440, 300. Diagonal matrix are positive. Then next one is a force equal to load vector, force equal to A alpha delta T minus 1 to 1 matrix form. Then here examples. Assemble of element equation, F is equal to K into U, F is equal to K into U. Then U is equal to nodal displacement, U1, U2, U3, U4. U1 and U4 is equal to 0. Then final result, reaction 1, 249 into 10